Hi everyone. In the given problem statement, we are going to solve average of levels in a binary tree. So we are going to given an root of a binary tree. We have to return the average value of nodes at each level in the form of an array. So now let us take this example of this tree, which is going to have a value of 3, another left child of 9, 20, 15, and 7. So we can solve this problem easily if I follow the breadth for search approach. Sorry for my pronunciation, I made it a mistake. So now out here, we can initialize a DQ. Initially, it's going to have a value of root, and we can have a result, which is initially going to be empty, and our count to count the number of nodes in that level. So initially the count is also going to be 0. Now what we can do, let me add, let's say, dq initially and the result. So initial value of dq is going to be 3 and result is empty for now. So once we get 3 right, so we are going to we are running an while loop for our stack or for our dq until it's empty, and then we are going to check how many nodes or how many values are currently in this stack. In this stack there is only one value, so we're going to run a for loop into our stack. So it would be like while q, and then we are going to, let's say, here we can initialize our count, which is going to be 0 for now, and we can have a temporary value, temporary sum, which is going to be 0 for now, and then I'm running a for loop. So for in range 0 to current length of the stack or current length of the dq. So here it is going to run for one time because our current value of our dq is only 3. So here what I'm going to do, I'm create a variable called cur, and we can easily take out the value or of dq. So it would be q dot pop left. So whatever value is there, it is going to popped out. Whatever value it had, it got popped out. So 3 got popped out. Now what we are going to do, we are going to add that value to our temporary sum. So temp sum plus equal to cur dot val, and also our count, we are going to increase it by plus equal to 1. Pretty straightforward and easy to do. So once we have done that, so now the simple thing, right, we are going to check for the left child and right child. So I can say or I can just type in, right, if the cur dot left is present, then what we are going to do, we are going to do q dot append cur dot left, and similarly if cur dot right is present, so q dot append cur dot right. So it does have one right node, so which is 20 and 9. So 9 and 20 are going to get added to our dq. Now once that is done, right, we will have our count value. So count would be now 1 and the sum is 3. So what we are going to do, we are going to, in the result, right, we are going to store So res dot append, it would be temp sum divide by our count. So our count would be 3.0.0 something. So 9 and 20 we got. Again, we are running it up. So we have two values. So again, we are going to get initialized by 0 and 0 for the first time. Now for the first one, 9 count would be increased to 1 and the value would become 9. It does not have any left or right child, so nothing is going to get added. Now we move on to 20. So count is going to get incremented by 2 and the value would become 29. So 29, but it has two children, 15 and 7. So 15 and 7 are going to get added. Now we're going to add this value 29 divided by 2, which would be becoming 14.500, something like that. Now, the next time we're going to do, again count would become 0. Everything is going to be 0. And all of these are popped out. So 15 got popped out here. So the count value would be now 1. And this is going to be 15. Now here 15 does not have any left child or right child, so nothing is going to get added to our DQ. Then 7 is there, so the count value is going to get added to 2. I do 15 plus 7, which would be 22. So 7 does not have any left child or right child, so we are popping it out. And here we are going to call this res.append, whatever temporary sum that we have, divide by count. So it would be 11.0.0, something like that. So it's pretty straightforward problem if you're following a DFS approach, and maybe that's the reason it's an easy problem. And the time complexity of it is going to be bigger of n because we are traversing all the node one time. Obviously, there would be some complexities involved with the calculation, but apart from that, it's pretty straightforward. Now let us jump to the Python solution. Once that is added, we are going to check for all our trees that if the root is not empty, right? So in case the root is null, right, we are just going to return empty list. Now we are going to create a queue, which is going to be collections dot dq, and where the initial value is going to be root. And also we're going to create another variable called result, which would be an empty list for now. Here we are going to store the average sum or average value of all the levels in a binary tree. Now we are going to loop through it till our queue becomes empty. Now we are going to create two more values, sum x, which is going to be 0, and we can have a count variable, or you can just, let's say, loop through and just take a length of our current value of q. That would be also doing it up, but let me just, for the sake of easier understanding, let me create a variable called count, and I'm running it through for all the values that are present in the current DQ. So for underscore in range 0 to length of our q. Now after that, we are going to create a variable called cur, and it would be q dot pop left. So you're removing an element from the left hand side of our queue. Now we are going to say sum x, whatever the value is, cur plus our current root value, and our count plus equal to 1. And now we're going to do mandatory checks whether it has a left child. So if it has a left child, it would be q dot append cur dot left. Similarly, if it has a right child, so it would be cur dot right, q dot append cur dot right. Pretty straightforward. And at last, we are going to do res dot append cur, or it would be our total sum, means you're going to add the average value of that level. So sum x plus or divide by count, and at last we're going to return our result that we got out. Again, I'm making a mistake, which would be collections instead of collection. Now let me run it up. I hope it works unless there are some spelling errors. Showing a network error. As you could see, the public test case is passed. Let me submit the code. And as you are aware, the time complexity would be big O of n because you're traversing all the node once. So here, maybe because of the operations that we are doing, it is taking some amount of time, but here it is beating 100% of the submission, so our code is pretty efficient. That's all for this video. See you in the next one.